Hey guys! Welcome back to my channel. In this video we will talk about what is substitution reaction. But before that we make sure to subscribe to our channel and turn the notification on. Substitution reaction is a type of organic reaction. This reaction involves substituting one atom or a group atom into the saturated organic compound. Note that unsaturated organic compound does not undergo substitution reaction. They undergo addition reaction. If you are not familiar with the addition reaction, you can watch this video in our channel to be familiar with this type of reaction. Back to our lesson. Alkanes is one of the saturated hydrocodone molecules. In this reaction alkanes reacts with the different types of halogens to form haloalkanes. This reaction always needs one of these conditions, which are including UV light or temperatures of almost 200 Celsius. For example, bromopropane. During this reaction UV light is needed as well as the presence of the bromide halogen atoms. During the process, one of the hydrogen atom from alkane is replaced by one of the halogen atoms. As a result it forms bromopropane. And the other atom of halogen will bond with the hydrogen that was replaced. This leads to form the byproduct of hydrohalide. In this reaction the hydrohalide is hydrobromide. This was just a simple substitution reaction. This reaction can also lead to create more types of haloalkanes, which are including dihaloalkanes, which means there are two halogens, trihaloalkanes, which means there are three halogens in the main chain, tetrahaloalkanes, which means there are four halogen atoms that has been bonded to the main chain. Here is an example of formation of dihaloalkane. In this reaction the chloroalkane is reacting with chlorine atom. Under UV light or heat, hydrogen atom is replaced by the halogen atom. In this case chlorine, which leads to form dihaloalkanes. In this case is called dichloroalkane, with byproduct of hydrochloride acid. There are different types of haloalkanes, including primary, secondary, tertiary, based on the number of halogen atom present, or based on the position of the carbon atom that carries the halogen atom, is the only difference between them. Their geometrical structure will affect on the rate of activity, or based on the position of the carbon atom that carries the halogen atom, is the only difference between them. Their geometrical structure will affect on the rate of activity. Primary and secondary have high rate of reactivity than the tertiary haloalkanes. Note that the carbon and hydrogen has been bonded through the polar type of bonding. Reagents that can substitute instead of halogen atoms are limited, which are including cyanide, iodide, hydroxide, chloride, ammonia, acetate, hydride and methanol. In cyanide substitution, the halogen atom will be substituted by the nitrile group which is Cn. In ammonia substitution, the halogen will be substituted by amine functional group, which is NH2. And the halogen left over will bond with ammonium group. In addition of iodine the halogen will be substituted by iodine atom. Keep that in mind that iodide is the most reactive metal of halogens. Then bromide and chloride. In addition of hydroxide the halogen atom will be substituted by the hydroxyl functional group, which is O. Keep that in mind that the type of haloalkane is especially important, as it determines the type of reaction. For example primary haloalkanes undergo substitution. Secondary haloalkanes under substitution and elimination. Note that in order to substitution reaction to take place heat and different solution, as it was noted previously, are a must. I hope that you enjoyed the lesson with us. Thank you for watching my video.